Good. Okay. Hey, hello. How are you? Can you hear me? Hello? Hey, I think I can hear you now.
Okay.
How's everything?
What?
How's everything?
Good.
Yeah, I heard that you got back to school, or is it in person now?
Yeah.
How was that?
So we had in person on Monday and Tuesday, but today and tomorrow are on computers.
Okay. Well, at least there's some, partial, you can see your friends and whatnot. That must be exciting, so. So like, I heard from your mom that you guys are doing a few, like, I guess so. Do you remember last week what we talked about the word problems?
Yeah.
So like that was good. I'm glad that you like that. It's we're gonna go back to that again, but after a few more like mathematical, concepts. But anyways, like from what we've been doing for like 2 weeks, it's a lot of it was pre-algebra. Like we've been just working with numbers, right? And I guess for the next maybe like 2 to 3, 4 weeks, I we're gonna dive more into like variables or algebra. What did you guys do this week, like for your math?
We didn't really have math homework, so my mom just made me do the worksheets.
Oh, she printed it. Okay, that's good. How are those?
Uh, so yesterday I did dividing fractions.
Okay, yeah, that's good practice. Is it helpful though, like doing those on the side, like besides like today, like doing this online? Does
Yeah.
it help out? Okay, that's good. I'll provide you more. Like, you know, your mom's like wanting you to succeed like every with this, and she might be busy, but do you mind just like every time we're doing something here, then you can just practice. Like the worksheets are all kind of like they're not organized, but you may have to look for the ones that match what we're talking about here. But just see if there's like a few that match. Anyways, some of the curriculum that I'm hoping to cover here, it may get complicated. I think you probably touched on it before, but have you heard of like exponents and scientific notation?
Exponents.
You've heard of exponents. Okay. What about rationale? We've been doing a lot of that, and then like we also been doing. Here, so we've been doing rationale, right? That was like all the fractions.
Yeah.
And we kind of touched on this variable expression. Remember we had like x plus 1 equals this guy, right? Something like that. So this is like a variable expression in essence. And what about square roots? Have you done square roots before?
No.
Have you seen this symbol? This guy?
No.
Okay. Okay. At least I kind of can gauge like what we can touch more on. But technically a radical, like they call it a radical, is kind of just like this guy, this whole symbol right here. Like if you were to take, this is called a square root. This guy right here is called a square root. So like if you were to do this, right? Do you remember like if you had 4, like, and if you did this, I'll explain it in a bit, but if you do this, this would be 2. And like we'll cover more, but an exponent is technically, you know, like when you have an exponent, remember the little numbers up here? This guy?
Yeah.
This is called the exponent, right?
Yeah.
Okay. So like these exponents are just the same as this guy. So take it like this. So like if you were to do 2 squared, what is that?
4.
4, right? Okay. And then when you take the square root of 4, you get what? 2, right? Like right now it's like that's what it is. Like you when you take a square root of something, so what was this? Like this is 4. Let's try plug in 2 to the second here. It's the same thing, right? This guy equals 4.
Yeah.
Okay. So this square root right here, just to give it like in terms of an exponent, because this is pretty much written as an exponent. You can do it the same way. If you did like 2 squared, right? And then you wrote this guy as an exponent, it would be 1/2. And it's just pretty much an exponent. A square root symbol is pretty much just an exponent. So let me see if I can explain this one. So 2 squared, right? And then you have this 1/2 in here, right?
Yeah.
So when you do this, like you're taking this whole thing right here, 2 squared to the 1/2. Have you guys talked about rules of exponents?
No.
Okay, I'll touch on that one. So I guess this is a perfect time to do that. And this is just an example, but when you have this guy, a number inside this 2 squared raised to another power 1/2, right? This is the power, an exponent. You just times it. You just times it by this guy. You just times the little numbers up top. So like, you know how like this guy is up top and then this guy is also up top, like upper numbers? All you have to do is times those numbers. Does that kind of like make sense? That's like one of those rules. And then, so what happens up top? Like, what do you do here? You have this 2 times 1/2. What is that?
With the big number or just the small number?
Just a small number. Just this one inside the parentheses. What is that one? 2 times this guy. 2 times 1/2.
1.
Yep. So this guy equals 1, right? The small number. The small number equals 1. So altogether, what is this? 2 to the 1? This is 2 to the 1, right?
Yeah.
And then what is 2 to the 1?
2.
And then what was this guy? It's the same, right?
Yeah.
So what did we just like talk about? Like, so 2 squared, this square root sign. The square root sign is the square root of 2 squared inside equals 2, right? And then So this square root can also be written as just a 1/2 exponent, right?
Yeah.
That also equals 2, right?
Yeah.
So this whole thing is equivalent, like all of this. Like if you take a look at this square root and then you take a look at this 1/2, it's pretty much the same thing. The 1/2 and the square root. And that's why, you know, when you say it's a square root, right? It's called a square root. Because like when you say it's a square root, it's pretty much the root here being 1/2. That right now it seems very confusing, but like that's just what it is. Like when you take a square root of something, you're pretty much raising that number inside to the 1/2 power. Okay, let's talk more about like the other rules. Just like other rules. This is like basic stuff. So let's say exponent rules. All right, so let's talk about this guy. So for example, you have this first thing. This first thing is called a product rule. So let me know if something seems unclear. So the product rule, and what you do here is kind of like what we did, but you're not raising it to, you're not multiplying the small number. So for example, let's have 2 here, right? And then you have this 2 raised to like 5, small number 5. And you want to times this 2 by another 2 raised to like the second power. So small 2. So this product rule right here, what it tells you is since you have the same, like, you know, big number, same big base number, you can just do this. So I'm gonna write it first and I'll explain it. So you can just write 2 again, and then like your exponents, you have to add these guys. So when you do that, what's the small numbers add up to?
7.
So it's 7. So this is called a product rule. This right here is like, you know, when you're multiplying 2 numbers that have the same big number, base number, but different, or it doesn't matter what their exponents are. If they have the same base number, then they're being multiplied. That's why it's called a product rule. Product means like multiply. Then you can just add their exponents. Does that kind of make sense?
Yeah.
Yeah. So this is like one of the easy ones. This next one is so you have a product rule, right? So you must also have something else that's a division. So we call this the quotient rule. So the quotient rule, what this is kind of similar, but then now instead of multiplying, you're gonna have like, so I'll use the same numbers. So 2 to the 5, and you divide this by 2 to the second. 2 to the second. So now let's take a look at this. So you have the same base number, big number, but different small number exponent. And now they're being divided. And that's why it's called the quotient rule. So when you divide, you know, these guys, it's pretty much the same thing as, so since they have the same base, you just write the base again. And then instead of adding, you're gonna, what do you think you're gonna do with them?
Subtract.
Yeah. There you go. So that's it's not bad. So this is 3. Like, you know, I mean, this one isn't like that bad. It's just like right now. Let's talk about the rules and then we'll apply it. But these two, it's doable, right? These two guys make sense, right?
Yeah.
Okay. Now let's do more. There's like a couple more. Just a bunch, like algebra, you know, once you, like before it was just a bunch of like, we talked about adding like, you know, whole numbers. We talked about multiplying, all of doing those operations with fractions. And now we're just like doing that, like there's rules for those. Now we're just doing that with exponents. So we're just adding like numbers with small numbers up top. There's just a bunch of rules that we have to like talk about and then know. So this next one is called a power rule. So let's talk about this power rule. So do you remember that one where I said like you had this guy, right, inside, and then you had 1/2 here, right?
Yeah.
So there, sometimes people get you know, mix this up. They make a mistake with the power rule and then the product rule. I'll tell you the difference and let me know if like, oh, like it seems confusing. But when you do the power rule first, what that means is like you already have something inside the parentheses that's like being raised to a power. It's already being raised to a power. So the second, you know, that's two, the small 2. And then this inside the parentheses, you want to raise this whole thing by another exponent, another power. So, right, usually when you say exponent, it's like to the power of, so it's like interchangeable. Yeah, like exponent this. So this small 2 exponent, and then this like 1/2 exponent, but this 1/2 is raising both these guys. It's not just, there's no base here. So when you see something like this, you don't add these guys. You in the if you remember this one, you added them. But when you see something like this, like in this form, what did we do with them? What did we do with the 2 and the 1/2?
Multiplied them.
Yeah. So does that seem like it's clear? Because sometimes people don't, you know, when you see these two guys, when you compare like this guy right here with this guy, it seems like, why are you doing 2 different things? But like this one, you know, this one, like this guy is just pretty much, it's separate. You have another base here. You're not raising the big number to a power. But this one, you're raising the big number and the exponent to another power. And that's how you multiply them. But this one, you add these guys. That's probably like the most confusing one, if there's anything else. But does it make sense though why you have to multiply these guys?
Yeah.
Okay. Okay. I mean, yeah, like all the other ones are simple. It's these two, the product rule and then the power rule. If you got that, that's like really awesome. So let's talk about number 4. So this one, oh yeah, this one is it's kind of like, it even gets you know, you're combining 2 things there. So the power of a product rule. So the power of a product rule. So let's take a look at what that means. So we talked about the power rule, and we also talked about the product rule. So what is the power of a product rule? So let's take this guy. So what if you had, let me see, what if you had, let's try to just use variables. Like, so you had 2x, because I don't want to multiply these guys. So you have 2x here. And then I want to raise this to like a set, just 2, you know, 2 power, second power, exponent 2. So here's your exponent, right? It's also inside of parentheses, right? But then, like, now you have like these 2 guys. You have a 2 and then an x. You have 2 and an x. So this is kind of like the, there's a product right here. So that's going on 2 times x. And then when you raise this 2 of them to the second power, this is what you have to do. So you do 2 squared and then x squared. And that's pretty much like when this guy is being distributed to here and then to this guy. So that's why you have 2 squared and x squared. So the 2 right here is being distributed to both the 2 and the x, or whatever's inside. Does that kind of make sense? Like if you were to look at another one, like 4x and then to the third, it would just you would just take this number right here and give it to the 4 and give it to this other guy. X cubed. Does this one make sense?
Yeah.
Okay. It's kind of like this one's kind of like the power rule, right? Because you have like, you have this exponent that's in, raising this guy inside to another power. Let's do something like a little bit complicated. So what if you had this other guy? It's kind of like the power rule, but let me see if you can get this one. So what if you had like 2 squared and then you had x to the third, and then I rose all of these guys by the second to the second. So what do you have to do with this one?
Two squared
Okay.
times x cubed.
2 squared times x2?
X cubed.
Okay. 2 squared times x cubed. Let me see. 2 squared times x cubed. And then what about this guy? What do you do with him?
Add him.
You have to, like, kind of similar to this one. You multiply him, right?
Oh, yeah.
Because it's the same as this. It's just like a combination, a power of a product rule. So like when you have like these things, like it's a parentheses, and then you have all this raised to like a power, you have to do this. So 2 to the second, 2 squared times 2, and then x to the third times 2. So it's like 2 to the 4, x to the 6. How is that one? That one's a little complicated.
Yeah.
But that's what you have to do with that. What about this one here? You can combine these ones. So what if you had 2 to the third, and then you plus 2 to the second, and what if you raise this to like, what if you raise this to the, I guess to the squared? What do you do there?
2 and with a small 6 over it, plus 2 with a small 4.
Okay, so do you remember your do you remember your PEMDAS? This guy.
Yeah.
So like, do you remember like the this e? What does it stand for? This is the exponent, right?
Yeah.
And then what about this p?
Parentheses.
Yeah. So since we have this parentheses first, we actually have to add these guys first. So like, yeah, no, it's like why do you do that? And there's an exponent here. So like, so what would you do here? So when you add them, what would your exponent be?
5.
Yep. So 3 plus 2, yeah. 3 plus 2 is 5. So 5. And then now this whole thing is to the second power. What do you do here?
2 times 5.
Exactly. 2 times 5. So 2 to the 10th. Yeah, so see, like, you're just combining it. And then the one thing is important is you have to remember this guy in the PEMDAS when you're doing these. Let's see if we can do, so that's not that bad. Let's do number, like, the rule number 5. The rule number 5, let's see. This one is the power. It's pretty much the same thing as like the product rule, but this is for a fraction. So now the fractions come in. So the power of a fraction rule. So this guy, what you do here, let's just give an example. So let's, maybe we have the same thing here. We have like 2, and we'll do something interesting. So 2, and then 2 to the power of like 5, right? So, and then you raise this guy to like the third power. So what you would do here is you do whatever's inside the parentheses first. And then when we're dividing these guys, you have to subtract the exponents. And then you raise them to the third power. So, what the inside here is what? Negative. So now you could do negative exponents. It's not just positive. So this is -3. Then you raise it to the third power. So that's 2, -3 times 3. And it's like 2, -9. What I usually do is like I try to break these down. Like it's easy to do like one step at a time. But that's how you do it with numbers, the fraction rule. Does this one make sense?
Yeah.
Let's try to do that with like not numbers, like one number, and then the other one is like an x. And then so let's try to raise them to the second power. So when you do this, the fraction rule just tells you to do this. So 2 to the squared, you pretty much distribute this guy right here, divided by x to the squared. So when you do that, kind of similar to what we did with the power of the product rule, where we distributed the exponent to the product, but this time we distributed the exponent to the fraction, numerator and then denominator. So that's kind of, in the end, it's going to be 4x squared. Someone asked you to simplify it. How's that one?
It's like the same thing as the power of a product, except
Yeah. Yeah, it's not that bad. I'll tell you something else too. I mean, this is a little bit like, it's not really, let me see if I can. Actually, no, so we're going to touch on that one. Let's talk about this next one. So number 6, I think, number 6. So, we can raise, you have like positive exponents, positive powers, and negative exponents, negative powers. And then why can't we have like a 0 power, right? A 0 exponent. We probably can. So there is a rule for that. So that's a 0 exponent rule. So this one is like an interesting one. And then people just like, once they know this, it's like, oh, okay. So everything raised to, for example, 2, I'll tell you a few of these things. So 2 to the 0 power right here. This is my 0. This is how I write it. But everything raised to 0 equals 1. So let me write another one. 3 to the 0 equals 1 again. X, any variable, it doesn't matter what variable it is, to the 0 equals 1. Very convenient, right? Like, once you reach like a 0 power, everything is 1. Like even this guy, if you did 2 times x, raise this to 0, this whole thing equals 1. Or like 2 over x raised to 0, this is also equal 1. What do you think of that one? That was probably the easiest one.
Yeah.
It's like, whoa, what? Like, but you know, when you do use this guy, a lot of times you use this to simplify something. Like when you can like for example, what if you had I'll show you when you use it. So like, what if you had like 2? Let me think if this is okay, 2, and then maybe you wanted to go like 2 to the like 2. No, that's not the one. 2. Oh, here you go. Yeah, this is actually, maybe you could do this one of 2 ways. So this is pretty much 2 squared is 4, right?
Yeah.
So this guy is what? 4 over 4, right? And what is that?
1.
1. Okay, let's do this another way. What did we learn about like exponents, power, bases of exponents when they're being divided? What do you do with their exponents? Like in this one, what do you do with their exponents? The 2.
Subtract.
Okay. So 2 minus 2 is what?
0.
Okay. And what did we say 2 to 0 was?
1.
So it's the same, right? 4 to the 4 over 4 is 1. 2 to the 0 is 1. That's interesting, isn't it? I always find that like, oh, okay, so you could do that 2 ways or many other ways. So like, yeah, like, I mean, you could just do this. You could technically just do the math or the arithmetic, or you can work with exponents and you'll get the same answer. So, and sometimes like, you know, when you have like, later on, we're going to be talking about solving for x, like, or 2 variables, x and y, which is, that's going to be the fun ones, you know, when you combine that with like a word problem. Like if you find a way where you can make a variable go to 0, then you don't have to solve for it, like, because it goes to, you know. And then also we'll be talking about something else later on that's going to be like the opposite of a exponent, but that's going to be later on. So let's see, number 7. So if there's a 0 exponent, and we talk about positive exponents, there's actually a rule for negative exponents. I'll just talk more about it. This negative exponent one is like a special one. Like you could do, I mean, sometimes like you just have to like know this rule. It's like, oh, once you know this rule, then you can use it in simplifying things. So let's talk about that one. So let's have a 2 again because it's simple. And then maybe make it negative, right? Negative exponent 2. So 2 to the negative exponent 2. So before we understand this one, before we talk about it, what was 2 squared? What is 2 squared?
4.
It's 4, right? Okay, good. So when you see this guy and it has a negative exponent, what you have to do is you could just write it as a fraction. So that's like a rule. Like every time you see this, and it's like there's no fraction here, but you have to write it like this. So there's a 1 over 2, and now since this guy is a negative. When you put it at the bottom, the denominator, it becomes a positive. So it's a positive now because it's at the bottom of the fraction. So that 2 to the negative 2 is 1 over 2 squared. So that's 1 over 4. So like, yeah, the negative exponents are like that. Like, you can make them positive as long as you switch where they are. So like, let's talk about that more. So switch where they are. So if you have this case, right? You have this case. You know, if it's like a whole number and it's negative, you just put it at the bottom, right? Does that make sense? You put it at the bottom?
Yeah.
You could probably also put it at the top. Like you could probably like, instead of putting it at the bottom, you go, but then, so how you do that is, what if you had this guy? 1 over, it's kind of like this guy. But now the 2 here is negative. So at the bottom, the 2 is negative. This is a negative 2 at the bottom. You just put it up top. You put it up top and you make it positive. So you put 1 at the bottom. I'm writing this even though like it doesn't make sense to put a 1 at the bottom, but just to make a point, you put it at the top. So it's 2, and then it's a positive number now. It's a positive 2. So you put this up top, and it's positive because it was in the bottom and it was negative. And this is 4. All right? And look, take a look at these guys. Like, they both equal 4. So that must mean they're the same, right? 2 squared is the same as 1 over 2 to the negative 2. I know, like, how does that work? Like, how they both equal 4, right? But they don't look like they're about the same, but they're the same, right?
Yeah.
So like, yeah, that's just like how you mess around with these exponents. Like you have to, like, knowing the rules, you can make them the way, like you can make this guy just applying the rules. And a lot of times it's really just simplifying like the number or the variable. Okay, I think we're into the last one, the last rule before we do the examples. Okay, so that's number 7. So let's talk about number 8. So number 8. So number 8 is called fractional exponent. Fractional exponent. It's a good thing we covered fractions because like that's like I said, like once you have that concrete, you can finally tackle exponents in scientific notation. So fractional exponents. What does that mean? Let's try to talk about it. So let's have 2 again. And then maybe we can have, this one's probably a little complicated to see, but I'll try to do my best to explain it. So if it's a fractional exponent, like you have, you know, whole positive numbers, you have whole negative numbers, you have a 0 that's a whole number as well. So why not have fraction exponents? That's what it means. So you can technically raise this to a power of 2/3, right? That's what the fraction exponent stands for. So it's like, oh yeah, okay, you can have a fraction as an exponent. So 2 raised to the 2/3. So like, you're probably like, what is that? How do you do that one? So this is how you do a fractional like exponent, because you could just put this in your calculator, but there's actually an easy way to simplify it where you could just do it by hand. So do you remember our square root sign? You remember our square root sign, right?
Yeah.
And what was our square root sign? It's the same as what? Raising it. Yeah, raising it to?
The half.
1/2. So just to explain that one, like, yes, that is the one because it's a square root. There's actually a number right here. There's actually a number right here. When you talk about the square root more, there's actually a number right there. So it's like, this is called specifically a square root. because there's a 2 here, and then it's 1/2. It's 2 to the 1/2. Same exact thing. So if we know that one, right? We know this one. Let me rewrite this one, actually. We know it's 1/2. And this is a square root, because there's actually a number right here. We know when there's no number there, it's kind of like, that's this, people know that sign. This is the same, just so that we don't confuse it. So this is the same as not writing the number. But this number can change, though. This number can change. So applying what we got here, let's talk about this guy. So like, we have 2 here, right? And then we also have 2 up top, 3 at the bottom, right? 2/3 raised to the 2/3. Let's try see if it's the same as this guy. Let's try to make that like kind of similar to what we did here. So this one right here is raising, this is pretty much like raising this base number, right? 2 to the squared. That's this guy. That's this guy. 2 to the 1 is pretty much 2, so that's why we didn't write it. But this numerator, this when you have a fraction exponent, you raise that base number by that number, by the numerator number. And then you're not done. The next thing is this guy. So the denominator number, the 3. Where do you think that goes? It's this guy, right?
Yeah.
It's that small number over here. So this was called a square root. This is called a square root. This one is called a cube root, because you have this guy, 3. So yeah, you can have a square root, and you can also have a cube root. You can have many roots. You could have a 4th root, a 5th root, whatever you want. But this right here is pretty much equivalent. So when you write, let's talk about other things. So maybe you have like 1/5, to the 1/5. That one's just 5 square root, or 5 root, and then put it inside, and then this number is 1. And what's the next? Let's do another one. Let's make it 3, and then let's have like maybe 2 to the 6, All right, that's not good. 2 to the 5th. So just writing it again in the same, thing as this, it'll be to the 5th. You have the root, and then the inside, and then the numerator. So does that one make sense?
Yeah.
Okay, so like that's pretty much exponents. There's another one we can talk about later, but let's try to do some of those examples, because I think that's a lot of rules already. All right, let's talk about this guy. Can you see the numbers? They're a little bit small.
Yeah, I can see them.
Okay, good. Let's talk about like doing some of these. So what this is wanting you to do is write using exponents. So like, for example, you have this guy, 8 times 8 times 8. And we talked about this, right? So when you have like something being raised, for example, I'll just write the way this is called the product rule, right? 8 to the 1 times 8 to the 1 times 8 to the 1. So what was that, the product rule? You just add the exponents, right? So it's 8/3. So that's how they got this guy, 8/3. So let's try to, we don't have to solve this. We're just trying to, apply the concept of exponents. So let's try to, these ones are really simple, really. Like, and I think knowing the basics is always good. Let's try to do this guy. What is this?
$1,000 with a 10.
Yep, that's the one. Good. All right, let's try to speed this one up. What about this guy? All right, hold up. This guy.
74 with a small 9.
3, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. And it's just pretty much counting that number, right? You're just doing the enumeration. Is there one as a good division? Let's see. Yeah, some of these are like it printed out wrong, so just you don't have to do these ones. Oh, what about this one? What about this guy?
1.
0 to the what?
1. Oh.
It can't be. This one is not 0. It's not 1. It's 0, right?
0 to the 9.
But it's 0, right?
Yeah.
Yeah. So if you were to have 0 to the 0, what about that one?
That would have been 1.
Exactly. Good. I like that one. Usually, like, a person's like, what is 0 to the 0? How can that be 1? All right, let's go see if there's another one. All right, this one has some other ones. Let's take a look at this guy. What is this one? Or like, let's write it first. So 0 to the 5th to the 0, that's what?
0.5.
So 0.5, yeah, to the 0 is what? It's 1, right?
Yeah.
So this is 1. And then times this by 0.7 to the negative 2. What do you do there? If it's a negative exponent, what do you do?
1
1
over 7 and negative 2.
It's up. You're
Wait,
gonna
no,
go 1.
regular 2.
Regular 2. Yeah. Yep. So yeah, when you're switching it, like it's on top and then it's negative, you put it at the bottom, it's positive. So this is correct. You don't have to evaluate it. So that's good. So what about, let's see. Oh, there you go, this one. So let me rewrite this one. It's negative 0.04 to the negative 2 divided by negative 0.001 to the 1. What is this? So this is negative, right?
Yeah.
So what do you do with that guy?
Put him on the bottom.
Yeah, so you still have this guy right here. And then you're timesing it by whatever you had up top. But then it's what?
Positive.
Yeah. So that's a simple one. It's just those ones that we got, because like sometimes that mechanics of like putting it at the bottom and changing it, it's just it's natural once you do more of it. So let's see. This one. Yeah, these ones don't. Let's see. What if you're practicing these ones? You can actually like do your arithmetic. You can actually find what that number is. So yeah, they're pretty easy. These ones are pretty easy. Oh well, let's do this one. What is that?
Put the 2 on the bottom. And the second one is 1.
Okay, so it's pretty much this guy, right?
Yeah.
Yeah. See, so exponents are not bad. They can get complicated as long as you remember those the rules I said. like those are the ones that's gonna make it complicated. Is like when you have variables. So now we talked about exponents. Let's extend that to scientific notation. So scientific notation. Have you heard of this before?
No.
Okay, I'll just say it in a very simple way. Is it's just writing something. So when you're writing like 285, let's just go with like 285. I guess it's like the same number here. You can write this using a decimal, with like a 10, and that's just what it means. This is the writing it as like this guy is like the normal way. This is the normal way, or the expanded way, and the scientific notation is this other one, which is equivalent to it. Is it always wants you to put it as like this once and then a decimal, and then you have this like, you know, tenths and hundreds. It's like this guy. So that's always the base form. Like you have to write it like that, move the decimal from here until you get like a ones unit only. And then you're probably like, why do you need to do that? And then this is not equivalent yet, so you have to times it, right? Times it by a 10. And then when you move a decimal to the left, how do you move it to the right? You remember doing that?
No. I only remember doing it to the left.
Okay, you only remember doing it to the left. Okay, good. So when let me just change this. When you're moving it, so now it's right here. I want to make it 285 again. It's 2.85 right now. So I'm moving 1 and 2, right? 1, 2 to the right to make it 285. So since I moved it twice, this is going to be a 2, right? So that's how you do that one. It's right now it's like, okay, why can't you just write it as 285? But when you think about 2.85 times 10 to the squared, so 10 squared is what, 100. So that's pretty much equivalent. 2.85 times 100 is 285. The reason why you write it like this, scientific notation, is it's easy to multiply these guys once you do some operations with them. And then like, you know, working with like the smaller number than 285, you can, like when you operate, like for example, you have 2.85 times 10 to the 10th. I'll just show you this and then we'll see this again later. And then you also have like maybe 1 times 10 to the 3rd, right? And you're multiplying these guys. So you can just times 2.85 and 1. So that's what, 2.85, right?
Yeah.
And you're timesing these guys. So now you learn about exponents. That's why it's an extension. Now you can do 10 squared times 10 third. And what do you do with the exponents? You add them, right? That's 2.85 times 10 to the 5th. And it's easier to add them if they're like this than when it's easier to operate on them when you're doing this, is because like if you were to just do your long multiplication, it would be just this guy times 1,000, right? Something like that. And then when you do this, let's see if it checks out. Let's see if this one right here is the same as this guy. It's the same, right?
Yeah.
So that's why you do the scientific notation. There's other ways. Like sometimes when someone asks you to write it that way, later on, like in maybe like class like a higher level science class, you're gonna see this in science class as well. It's like a lot of experiments. They like to work with scientific notation rather than the normal way. But the most important thing is going converting normal to scientific notation. You gotta go like from scientific to normal and normal to scientific. That you have to do that interchangeably. So let's try. Does that make sense? Like this thing?
Yeah.
Okay. So let's try to do some practice. Yeah, this thing, like it's just like a concept. It's not that hard once you get a hang of it. So let's try to write this guy in scientific notation. What do you do first?
times 10.
Okay, so you move the decimal, right, until you get a ones here, right? So, and then you keep everything. You don't drop anything. So it's 2.8512. 2.8512 times what? Times 10. 10 to the what?
To the 10 squared.
Yep. So you're just counting like decimals pretty much when you're doing these guys. So that's correct. This one's good. What about this guy? 3.705 times
10 squared.
Yeah, it's pretty much the same. Let's skip some. Let's make it harder. Let's go with this guy. 4.662483 times 10 what?
10 cubed.
10 what?
Cubed.
10 cubed. Okay. What is this? Okay, sorry about that. Okay. 10 cubed. Okay, that's right. So let's do something. Let's do something like harder than these guys. Let's do this one. So what do you do first? For this guy, where do you put the, or tell me what to write, I guess.
I don't.
So like you move the decimal, right?
Yeah.
You move the decimal until you get a ones. So what's the ones? It's 2, right? If you, and then you put a decimal right here.
2.51248026.
Yeah, that's a mouthful, but and then you times it by what? 10 to the
5.
Yeah. It's easy, right? It's like it's pretty much the same number. Why would you do this? But yeah, like I said, it's easier to multiply them once you do that scientific notation. Let's do. Sometimes there's a negative one as well. You could do it like a negative one. Let me. There's not one here, but you could easily do like 0.00523. So let me explain this one first. Let's make this a scientific notation. Everything here is like bigger than 1. I wanted to do something less than 1. So when something is less than 1, you do the same thing. You move the decimal until you get a ones. So it's going to be 5.23. And same thing, you times it. But like you moved it to the right. But now like this 5.23 is not 0.00523. Where do you move your decimal to get this guy?
To the left.
To the left, right? To the left, exactly. So it's like, so let's count that. 1, 2, 3, right? So is it positive 3 exponent or negative 3 exponent?
-3.
Negative 3. So like, let's just check that one. 10 to the negative 3. Yep. I mean, it checks out. So that's like a 5.20 times 10 to the negative 3 is the same as this guy. The one thing here is just remember where you're moving your exponent to, or like where you're moving your decimal to equal whatever that exponent number is. Because the number of times you move it is your exponent number. And if you're moving it to the left, it's negative, right? And if you're moving it to the right, it's positive. It's just small rules. Those are just the small rules. Like in scientific notation, any number that's given to you, make sure you get like a ones and like a decimal and then a bunch of the tenths and hundredths, whatever. This is what you have to do. You times it by a 10 to an exponent, and this exponent is the number of times you're moving this guy. You're moving it to the left, It's negative. You're moving it to the right, it's positive. Does that one make sense?
Yeah.
Yeah, it's if you practice these ones, like these ones are the ones that we have here are pretty much they're kind of easy because they're all like bigger than 1, so they're all going to be positive exponents. I think. Yeah, it looks like it's positive. There's none of these guys are negative. So let's see if let's try to look at this one. Okay, so the first one is telling you to write it in scientific notation, right? This one is trying to tell you write it in normal form now. So there's normal form. So the normal form is pretty much the number without what we're used to, what we're used to without the 10. So pretty much like you're just gonna be moving like decimals again with the number of the exponent. So what do you think this guy would be?
144.57.
Yeah. So this one, this one. You're used to doing this one. Like it's just what is the scientific notation? These ones I know. Like when someone gives this, like for example, this guy. What is this guy?
59556.
One more, right?
Yeah, 5.943.
Exactly. So this is the normal form. So given the scientific, give me the normal form. And then the other one was normal form, give me the scientific, which is the harder way. That's like the harder way. This is the easier one. Let's see. Let's take a look at like this guy. None of these are that hard actually.
Can I go get a drink?
Huh?
Can I go get a drink?
Oh yeah, go ahead, good. No worries. All right. Okay, let me see. So let's take a look at a few things. So this one isn't that bad. Let's try to do something else here, which is like really, because they never give it to you in like negative form. Let's try doing this one. What is that?
0.0985.
Exactly. Okay, so this one isn't that bad. Let's I think with the time that we have, let's take a look at, and we'll continue this next time. I think it's good to take these apart, just and like do some more practice. So like for this one, you have like variables now. So instead of like numbers, you have variables and then like the exponents. So let's do some of these. So for this one, what is this? So it's 2m squared times 2m cubed. What do you do there?
3 plus 2.
So 2 plus 3, okay. And then that's what?
2m and 5.
Yeah, good. And then let's try do like this guy. So this is 4 actually. 4, because you're timesing the 2. M to the 5th. And so what about this guy? So 4 times 2, right? And 4 minus 3.
8 and 1 and 1.
Yep. So it's just 8n. Okay, so let's do a couple more. Let's what about this guy? This one looks complicated. So what do you do here?
Four.
And then so x, right? I would probably like do this. So x, like separate them. So you have this -1, right?
Yeah.
And then you have y. You have -3, and then what was it? +3?
Yeah.
All right, let's take a look at this. So 2 times 2, and then you just break them apart. 2 times 2 is 4. And then this guy is what? X squared. Yeah. And this one is
Y, 0.
0, which is what?
Yeah.
Y0 is what?
1.
1. This whole thing is 4x squared, right? Yeah, that one is a little complicated, but what I would do there is just do this. And then so let's take a look at maybe like this guy. So you do this one, right? 4 times 3. And then what do you do next with this one?
A 3 plus 2. Wait, 3 minus 4.
3 minus 4, okay. And then B what?
2 minus 3.
2 minus 3. And then you just simplify them. So you do 12. A.
And -2.
So this one is what?
-2.
3 minus 4?
Oh, 3 minus 4 is -1. And then plus, oh. And then, yeah,
What is
B is -1.
-1? What is a negative exponent? What do you do there?
Put it on the bottom.
So it's 12 over what?
A1, A.
And then?
Times
I'm not even going to put the 1 because it's just A. Okay, times what?
B.
B. So 12 over AB, right? That's the answer, yeah. Yeah, that's pretty good. And what about this guy?
1.
Yep. So anything that is 0 is 1. And what about this guy? So this one, I would distribute the -4, right? And then, but you're timesing it. You're timesing this guy. 2 times -4. In essence, you know, like this 2 right here, this 2 has a 1, so you're timesing it by -4. So this one's a little bit complex. So 2 to the -4, and x to the what?
-8.
Yep, x and negative. So what do you do with these negative ones? They're both negative.
Put them on the bottom.
So was it 2 to the
4 and x to the 8.
yeah? You could simplify this one. I think this is 16. Yeah, but that's how you do that one. So let's take a look at this one. What about this guy? So now the zero's inside. Try to apply what we did here. So what do I write?
4 times 0.
4 times 0.
4r. And then on the exponents, it's 0 times 4.
What about this guy though? Don't I need to have an exponent with this one? Isn't it 4 to the 4?
Oh, yeah, 4.
Okay. Yeah. Every time you have this like parentheses, you have to distribute the exponent. So 4 to the 4. And what is r 0 times 4? What is that?
R to the 4.
Well, this is 0 though.
Oh, then 1. Just r.
So r to the 0 is
R.
R to the 0 is anything to the 0 is
1.
1, right? Like any variable to the 0 is 1. So this one right here, 4 to the 4 is your answer. Okay, that one isn't that bad. Let's take a look at, what about this one? So same thing, what do you do with the -1?
4 with 4 to the -1.
4 to the -1, okay, and x.
To the -1.
And then y to the
-1.
Exactly. So they're all, like, that's what you do. That's the like power of the product rule. And they're so all of them are negative. What do you do with them?
Put them on the bottom.
Okay, 4x and y, right? So that one isn't that bad. Let's see. There's maybe 3 more, and then we'll call it a day. What about this guy? What do you do when they're being fractioned or divided? So okay, let me do this one. So when you're dividing them, you could do this like by doing this one of 2 ways. I usually just you have this bigger number at the bottom, right?
Yeah.
And I don't want any negative exponents. So I could transfer this guy at the bottom and make it negative and minus them. So you can do this 1 over 2 r3 minus 2. That's something you could do. So because this one is bigger, and when you're dividing them, you can just pretty much subtract them. We'll do more of these, but this is what you do. 1 over 2 r what? To the 1?
Yeah.
Yeah, so it's 1 over 2 r. What about this guy? Applying that same thing we did here.
One over 4x and then 4 minus 1.
Okay, so that one, this is a tricky one. So this is -1 right here, right? So when you're putting it at the bottom, what do you do?
Add it.
So you add this one. This one you have to add. So because you're going to add the one. So it's 1 over 4x to the 5.
Yeah.
All right, let's do this one. What about this guy? We'll do 24 and then 26. 24, okay. What is this one?
1 over 2m.
2 and what?
1.
So let's take a look at this. So you have this 4 here, right?
Wait, 0.
0, yeah. Yep. So what does that mean?
It's 1 over 1.
1 over 1 when you have a 2 here though, right? So this is a 1. Right?
Yeah.
So it's 1 over 2, but the variable disappears. See, that's what happens. Your variable disappears since you simplify. It's just 1/2.
Okay.
Let's do 26, and then that'll be our last one. Okay.
Okay.
This one's a complicated one. So you have this 2. You just break them apart, pretty much like So you have 2 and 3, and then whatever is up, like whichever one is high, like minus it to that guy. So you have x here, right? And then this guy is 4, right? Higher than the 2 here, right?
Yeah.
So you do this 4 minus 2. And then what about these guys? -4, -3.
-3 is higher than -4.
Okay. So you do this -3 and then what? +4, right?
Yeah.
And what about this guy? -3 and then 4.
4 is higher than -3.
Exactly.
So 4 plus 3.
I don't want any negative exponents, so that's good. That's always the rule. Like, I don't want any negative exponents. And then you simplify this. So it's 2 over 3 x. 4 minus 2 is what? Squared. And then y. What is this one?
1.
1. So I'll just leave it as is. We don't need to put to the 1. And then z is what? Z to the
7.
Yeah. So that's pretty much it, right? Like that's what you do. Like you're just applying all these exponents rules while you're evaluating them. Like knowing how they're applied now, you can probably, because the next step after you do this, after you simplify it, is you can solve for it now. Maybe you have like 3 equations. We'll talk about the equations next time, like solving an equation. Because if you remember, you can just easily solve this guy, right? You can solve this guy. So if I made this guy equal something, you can solve for one of them. You're gonna need like 2 more equations to solve for these other guys. Okay. I think my thing is usually I try to get you like 15 minutes. How was today? Is this like doable?
Yeah.
And do you mind doing a lot more of these practices this week? And I guess we'll do more next week, but then we'll touch on something that you probably seen before, like inequalities. Have you heard of that?
Yeah.
Yeah. So inequalities, we'll talk about how to solve and graph inequality equations. So we'll start talking about equations next week, more about it. And then like solving like multi-step, like this guy, the 2x squared over 3 equals 3. We'll do more of this and then more complicated ones. Cool. Hi, Mila. I think that was good. Let your mom know I said hi, and then yeah, have a good week.
Bye.
All right, see ya.